system, medium scale embedded system, and large scale embedded system. And we have started discussing about the purpose of embedded system. Okay. So now, when you start talking about your purpose of the embedded system, we have seen in the today's class. Okay. Screen share. So just I have brief it out in the yesterday's class. What is the purpose of the embedded system? Okay. So we have seen that the embedded system is going to be designed to serve the purpose of so dear students, from tomorrow, so please join 5 minutes of the beginning of the class. So if not, it will not cover the portion since the portion which we want to cover is vast, so it will become difficult for us to cover the portion also. So I sincerely request you people to attend, enter the class within 5 minutes. That is, if the time is from 1:30 means you have to join within 1:35. If not, I will not allow you people. So please maintain the timing. So now in the last class we discussed about data collection or storage representation, data communication, data processing or monitoring, control, application specific user interface. Okay. So now we will see one by one what are the different data collection or storage, what are the different purpose of one or more of the following tasks. So if we take the data collection or storage representation, so this type of embedded system is going to perform the acquisition of data from the external world. That means you are going to get the data from the outside world and you are going to store that particular data and you are going to analyze that data and manipulate the data and transmit that particular data. So for example, in this particular data collection, storage and representation is your set-top box. Okay, is the best example in this type of with respect to the purpose, how the depending upon the purpose what you are going to have, how the embedded system is classified. So it is classified depending upon the data collection, storage and representation. So in this type of embedded system, so it is going to perform the acquisition of data from the external world. Okay, so now what is the purpose of using the data collection here? The data collection can be done for the purpose of storage, analysis, manipulation and transmission. Okay, so it is going to store the data. So when you are going to have the data, so that particular data will not be having any meaningful information. So I have to analyze that particular data to have the meaningful information. So if any manipulation has to be done for that particular data, I'm going to manipulate it and I'm going to transmit that particular data. So whatever the data you are going to get in this type of purpose-based embedded system is, so like text message, voice message, image, video, electrical signals, and other measurable quantities you are going to have. So here in this type of embedded system, wherever ES is coming in this one is referred as embedded system. Okay, so embedded system with an analog capturing techniques collect data directly in the form of the analog signal, as you are told that. So if you take the set-top box, so set-top box, so it is going to receive the signal through the antenna. Okay, so you're going to place the dish at the outside of your house, right? So in the top of your house. So what is the purpose of placing the dish there? So it is going to receive the signal. Okay, that particular antenna which you have been placed, that is the antenna which you have been used at the top of your building to receive the signals. Okay, so when the signal is received, okay, so the signal will be in the form of analog signal. Okay, so the signal will be in the form of the analog signal. So whatever the analog signal you are going to capture, that has to be first converted. That particular if you take the set-top box, that is inside your set-top box, it is going to convert from analog to digital and it is going to represent it. So now why it will be done so is, so you are going to have the some of the analog signals will be dropped there even in the transmission. So it has to recover that particular data. So to recover that data, some additional information has to be stored depending upon the guess. So now this particular embedded system is digital data. What it is going to do is first convert the analog signal to digital data. So whatever the analog signal you are going to receive, that will be converted into digital data using an A to D converter, and then it will be stored. Okay, so then it will be stored. That is what it is done in your encoding and decoding. So encoding and decoding you are going to have. So our modulation you are going to have. So you are going with the modem, right? You have studied the modem, I think. Modem you are going to know in your data communication. That means in modem what will happen? It will modulator and demodulator. So modulator is going to convert from analog to digital. Demodulator is going to convert from digital to analog. So that is what it is going to do. So that is where you're going to make use of the modem. So modem is mainly used for your internet, right? To access the internet. So this type of embedded system, that is your modem, is also a typical embedded system. What is the purpose of the modem? So it's converting from analog to digital data. And when they're sending the data, which is converting from digital to analog data. Okay. And then some of the set-top box you have seen now. So it is going to store the data, or so store the pictures which have been acquired, right? So those data can be stored. So once you have stored, you can replay that particular film or serial, whatever you are going to have. That particular film or series, you can run that particular video, or then run that particular video. So next is here, whatever the ES used to collect the data, and it will be collected data, they are going to make the analysis. That is with respect to the medical applications. So the data which you are going to collect, so that will be stored, and it will be analyzed. So there are some of the examples which are going to have this particular type of device, embedded device, is in medical applications. So they are going to have the digital CRO and analog CRO is the best example of that one. So digital camera is the typical example of embedded system used for data collection and storage and representation. So this is one of the example. Apart from this one, you are going to have set-top box is another example. And then you are going to have the modem. So the modem is also one of the typical example of your data collection, storage, and representation. Okay. So next is data communication. So when it comes to data communication, so here embedded system using data communication like complex satellite. Okay. So and then simple home networking system. So in this, the data is collected in one terminal, has to be transferred to the another terminal located in the remote location. That is what the purpose of this particular this particular embedded system is going to do. So whatever the transmission you are going to do, the transmission may be either the transmission may be either wired or wireless. So whatever the transmission you are going to send, so that particular transmission, it may be wired or wireless medium which you are going to make use of. So next, the example here is wireless router, modem, and Bluetooth. So the data communication which you are going to have is more wireless router, modem, and Bluetooth is a typical example of data communication. Even the modem, you can use it in your that is a storage, data collection or storage also. That is a representation you are doing, right? So in the company, that is with respect to that one also, you can use the modem there also. They give an example. So data collecting embedded device system can incorporate data communication unit. So routers, switches are dedicated data transmission embedded system. So your routers, switches, which it comes. So this will also come with respect to dedicated data transmission embedded system. So data processing. So in your data processing systems, embedded systems, we are going to have the voice, image, video, electric signals, or other measurable quantities. Okay, so you are going to have the voice, image, video, electrical signals, or other measurable quantities collected by the embedded system, can be processed to get the useful information. Okay, so here the third type is your data processing. So that means you are going to have the data. So whatever the data you are going to have can be processed to get the useful information. Either the data which you are going to have, it may be image, or it may be a audio, or it may be a speech. That's live information which you are going to have. So the example is digital hearing aid. So in the digital hearing aid, what it is going to do? So it is going to it is going to improve the hearing capacity of the impaired person. That's what it is going to do. So next came monitoring. So in the embedded system designed under this particular category are used for only for the purpose of monitoring. Okay. So when you are going with the monitoring, so this particular embedded system which have been designed, so that will be used only for the monitoring purpose. Okay, so it is going to use to determine the state of some variable using input sensors. So as you have told you that it is going to determine the state of some variables using input sensors. You are going to have the sensors. With the help of the sensors, it is going to determine the state of some variables using input sensors. Okay. So the example is ECG. So ECG stands for electrocardiogram or MRI scan, which is there. So that's also one of the embedded system which you are going to use for monitoring purpose. So here, if you take the ECG, why this particular ECG is used? So ECG is basically used for monitoring the heartbeat of a patient. Okay. So ECG is basically used to monitor the heartbeat of a patient. So how it will be done? How the monitoring of the patient will be done? So the monitoring of the patient will be done depending upon the sensors used there. So sensors which are there will be used as the electrodes connected to the body of the patient. Okay. So once it is going to have the body of the patient, so it's going to have so now here what will happen is the limitations which you're going to have here is anybody. So as I told you that, so here it is going to have the example is which are going to have the digital CRO, digital multimeters and logical analyzers. So here the limitations which you are going to have when you are going to have the monitoring is they don't have the control over the variables. So because the monitoring will be done depending upon the input. So since we don't have the control about the input because the different at different instance of time, the different heartbeat is going to be generated, right? So I don't have the control over the input variable. It's keep on changing. So that is the limitations which you are going to have in your monitoring. So since they don't have control over the variables. Okay. So next is your control systems which you are going to have. So when you are going to have the build embedded system which will control. So here, so embedded system which are the control over the input variable. In turn, the other variables are controlled. That means as and when the input is changing, so the output also changes. So a typical example is the example which you are going to have when this particular book is written is air conditioner system. So now a system with control functionalities will have a sensors and actuators. So they are going to have two different devices which are going to have. One is the sensors at the input and the actuators. So what do you mean by sensors? Sensors is nothing but what you are going to get the input, that is what you want the data which you are going to sense. Okay, so whatever the out sensors is going to sense, so now the counteraction has to be taken place. Who is going to take that particular counteraction? The counteraction will be taken care by the actuators. So actuators connected to the output port are controlled according to the changes in the input variable. Okay, so according to the changes in the input variable, the actuators is going to control the input and it will put the impact on the controlling variable. So who is going to control that one? So that will put the impact. So other is your airbag. For example, in the car automobile industry, if you take the airbag, so what is the airbag is doing now? So airbag is going to open up if there is an impact. Okay, that is controlling. So depending upon what it is going to control, depending upon the impact of pressure. So if depending upon the impact, so whether the particular opening of the airbag in your car has to open it or not, that you should know. So now that depends upon the input variable. Here the input variable is nothing but what? Your impact. That is sensing that one. Okay, so the impact, the pressure sensor will be there. The pressure sensor, what it is going to sense? It is going to sense that with what pressure the impact has been happened. Depending upon the pressure of impact, whether the actual test has to perform the operation of opening the airbag. Okay, pressure sensor will sense the pressure of impact, whereas your actuator which is there inside your car, it has to open the airbag depending upon the pressure, how much pressure at the impact has been happened. So that is one example of your control type of embedded system which is having the purpose of controlling. Okay, the other is air conditioner. So air conditioner, we are going to have the control the room temperature to a specified limit. So because what we are going to have is, so in the room, in the home, what will happen sometimes, it may drop to the 14 degrees centigrade. So even if it is there, if that is decreasing to the 14 degrees centigrade, so according to that particular temperature, the AC has to control, it has to normalize the room temperature by itself. So it has to bring that particular 14 degrees centigrade to 28 degrees centigrade. So even the temperature increases inside your room. That means if it is increasing to 40 degrees centigrade. So even if it is going for 40 degrees centigrade inside the room temperature, the air conditioner, what it has to do, it has to bring down the temperature from 40 degrees centigrade to 28 degree centigrade. So that is how it has to be done. Okay, in your control system. So now next is application specific user interface. So in the slide, depending upon the applications, with applications, embedded system with application specific user interface like buttons, switches, keypads, lights, bell, etc. So with the help of this one, if any embedded system is working, then it is then that particular type of embedded system will come in the category of application specific user interface. So the example in this one is mobile phone. So because the mobile phone, what it is going to have, the mobile phone, the user interface is provided through keypads, graphic LCD model, system speaker, vibration alert, etc. So now depending upon the user, so the counter action has to be taken. So now again, their wearable device is there. So it refers to the what is a wearable device which you are going to wear. So like your watch is there, right? So typical watch embedded system is there nowadays. So which will keep on monitoring your BP, your pulse rate. What is your pulse rate? What is your BP? And what is how much this one oxygen level is there inside your body. So those things will keep on checking. So this variable device, even it will check the some of the variable devices which you are going to have, even it will check the heartbeat also. So now when you're having this particular, now whatever, there are many devices which are there, embedded devices which are there, which will serve many purposes. Why we are going with a embedded device is, you should know that. So even you can start your own company by building a new embedded system. So if you think, if you are interested in starting up your own company, so you can go with embedded device also. So like we have seen already that some of the examples like toy building we have seen. Then the toy building is a simple example where you can start a company from the base level. Okay. So only thing is you have to compete to the market. So whatever the product you are going to develop, that particular product, if it is a good quality, and with the good quality you have to, because as we are Indians, so we are prone to price. So what we want as an Indian is, so we want everything to be in less cost. That's what our mindset is. So I want the quality also, but the same quality what I require, so that has to be coming for me in lesser price. So now if you develop a product in such a way that which will be having the good quality of devices, wearable devices, and if that particular wearable device is costing less, then obviously the market, the product of your market product which is coming to the market will be hit. So you have to look in this particular aspect. So you have to give the product, good product. We have to give the quality for that particular product. And if you give the quality and the product, then obviously that particular product will be hit in the market. So that is how it has to be done. Okay. So next, after having seen the different classification depending upon the generation, depending upon the performance, and depending upon the purpose. So we have seen the different categories of embedded system. Once you have done, so next comes what is an embedded system, what it makes up of. So next, till now we have discussed only about what is the basic structure of the embedded system. So we have seen that embedded system are the systems which will perform the specific task. That's it. Now another example is what? If we talk about another definition of your embedded system, what it is going to tell? It is going to tell you that Embedded system is a electronic device or electromechanical system. So, which is designed to do a specific task, which is designed to do a specific task. That is one example what you are going to have. Now, when it comes to the real embedded system, what that particular embedded system consists of? Okay, so what is the definition of your complete embedded system? So that whatever the embedded system definition we have seen is a layman's definition. But when it comes to the actual definition of embedded system, what it consists of? So your basically the basic embedded system consists of three parts. Okay. So what are these three parts which you are going to have? The basic three things which you are going to have in your embedded systems are: one is your hardware, other is your software, and the third one is your mechanical component. So by using all these things, so what you are going to supposed to what you are going to supposed to achieve? So you are going to supposed to do only one specific task. Okay, so all these things are combined together, and you are going to make only one specific task to be completed. Now, if you take any single typical embedded systems, so what it contains a single chip controller. As I told you that one microcontroller will be there. So that particular microcontroller, chip controller which are there, which will be acting as a brain, master brain of that particular embedded system. So you are going to have the controller inside your embedded system, microcontroller or microprocessor it may be having, depending upon the type of the application for which you are building the embedded system. Okay, so depending upon the type of the application or type of the application for which you are building the embedded system, so that either you are going to make use of the microcontroller or you are going to make use of the microprocessor. So a typically embedded system, what it contains a single chip controller. So single chip controller is nothing but what? One IC. So inside that particular IC, I'm going to configure my application. What is the work that particular application has to do? So if you take the microcontroller in your mouse, so what is the purpose of the microcontroller inside the mouse? It has to, the microcontroller inside the mouse is what? It has to move the pointer, and whenever you are going to press the right click on that particular folder, it has to open the folder. Or if you want to select it, you have to right click it, or if you want to open it, you have to double click the using the on top. You have to go on top of that particular folder and you have to double click. So apart from this, any other function it is doing? No, it is doing only a specific task which has been assigned to that particular product to be done. So if you take the mouse, only three works it is going to do. Move, you are moving the pointer will be moving on the screen. Whenever you are going to click on the click your right button, which are the selected folder on the desktop, it is going to select that one. And if you want to open it, you have to do the right click and open. The options will come, you have to open it. So if you want to open directly, if you double click it, it has to open. So only limited functionality is doing there. So it is only opening the contents of the folder, that's it. Apart from that one, it is not doing anything. So this is what the definition of your embedded system. So basically embedded system is having three things. One is hardware, software, and mechanical components. Okay, so which is designed or supposed to do a one specific task, or which are designed to do one specific task only. So now it comes to the typical embedded system. So as I told you that it contains a chip controller which acts as a master brain of the system. So if you take the figure of your embedded system, the embedded system is going to look like this. So what are the different systems of your embedded system you are going to look like? A typical embedded system you are going to have like this. So what are the different parts it is going to have? You can see it here. So you are going to have the system core. So if you take any system, it will be having the input, it will be having the output. So now you can see it here. At the input port, you are going to have the sensors. The input port, you are going to have the sensors. So and the other output port, you are going to have the actuators, because depending upon the type of the input, what you are going to have, the system has to analyze that particular input, and the corresponding action has to be taken at the output. That's what it is going to do in the input port and the output port. So input port is sensors, output port is actuators. So okay. So next comes, so all of you know about the sensors and the actuators, I think. Okay. So next, when it comes to the So next, when it comes to the memory, so you're going to have the embedded firmware here. So you're going to have the firmware. So that is particular memory. And in this particular system, depending upon the type of the purpose of the embedded system, that particular system core will be having. So you're going to have the communication interface. So directly it will be connected to the system core only. This particular memory interface, communication interface, which you are going to have. So that particular communication interface will be directly connecting to the outside world, okay, to the system core. So next, when it comes to the other supporting components, so if you have that particular system has to be done, some data has to be taken and I have to analyze it. Whatever the data, it is going to process it. So the processing will be done inside the process core, system core, right? So when you're going to have the sensors input, the sensors will take the data. That's it. Once it takes the data, it will give it to the system core. Now, the system core, what it has to do, it has to process the data. So now the system core is nothing but a CPU, what it is performing. So it will be having its own memory, internal memory it will be having if it's a microcontroller. So if it is not a microcontroller, if it's a microprocessor, I have to add the external memory, right? So now when it comes to the memory, so it is going to connect to the memory system core. And apart from that one, it has to connect to the other supporting integrated circuit and subsystem. So these are the different parts which you are going to have. The system core which you are going to have in your embedded system, either it may be FPGA. So it is are the several cores which are existing in today's market. That is FPGA. So FPGA stands for Free-Field Programmable Gate Array. Okay. So we'll discuss these things in detail in the future. Okay. So it is there as part of your syllabus. So we'll discuss in there only when it comes. So next, it is going to have the ASIC. ASIC stands for Application Specific Integrated Circuit. As the name indicates, Application Specific Integrated Circuit. So that particular that particular integrated circuit is designed to do one specific task for that particular application. So it is going to have the application specific integrated circuit. So next is DSP you are going to have, that is digital signal processing. So next is SOC. SOC stands for System on Chip. Okay. So next it is either it may be having the microprocessor or microcontroller. So the system core may contain any of these six. Okay. Either it may be a FPGA, or it may be a ASIC, or it may be a DSP, or it may be a SOC, or it may be a microprocessor, or it may be a microcontroller. Okay. So apart from high-end applications, apart from if you want to do the complex operations, so only when you are having to design a complex applications, you are going to make use of the FPGA, ASIC, DSP, and SOC. So if we come till medium scale embedded system, okay, so we can make use using the microprocessor or microcontroller. So where these particular systems will be used, and this particular system will be connected to the external world through some of the component subsystem. Okay, so that's what it is going to have. So this embedded system are basically designed to regulate an physical variable or to manipulate the state of the devices by sending some signals to the actuators or device connected to the output port system. So in response to the input signal provided by the end user or sensor which are connected to the ports. So now what it means, so in the typical definition, what it is going to have, you are going to receive the sensor and you are going to analyze that particular data inside your CPU. That is, you are going to have the input variable from the sensor, right? So now after getting the input variable, it is going to process. So if you take the sensors with respect to the temperature of the AC, so what it is going to check? It is going to check that what is the outside temperature. So if you take the outside temperature, now what should be my inside temperature, which you are going to have? Okay, so that has to be taken, and we have to maintain that particular temperature with respect to that particular core. So it will give you that what is the present temperature of outside using the sensor. It will process it. Then what temperature I have to maintain inside my room. So assume that you have maintained that particular temperature to 28. So now what I need to do, either I have to increase the AC contents to that particular temperature, or I have to decrease depending upon the outside temperature. So now the automated cooling facility is also there in your AC. So if some of the ACs which you are using, if some of the people may be having in their house also, So if you know that one, they will come to know. So you have an advertisement with Amitabh Bachchan playing that one. So if you have seen that particular advertisement, you will be knowing that one. Okay. So what type of embedded system they have been using. Okay. So here the control is achieved by processing the information coming from the sensors and user interface and controlling some actuators that regulate the physical variable, as I told you that. So the data will be coming from the sensors, received by the sensors. Whatever the data it is going to receive, it is going to be processed in the system core. After processing it, what action has to be taken? That will be done by the actuators. The action which has to be taken, it has to be done by the actuators. So if we take the ASC, it is nothing but what? It is going to regulate the physical variable which you are going to have. Regulate the physical variable which you have got. So what is the temperature you have got? That is a variable. Okay, so that is having some data which you are going to have. So like you're going to have the keyboard, push button, switches, and some of the users interface used. These are the systems. So whenever you are going to have the systems, this embedded system should not require the human intervention. Okay, so it doesn't require the human intervention, but it is a works with the input from the sensors and produce the output with the help of the actuators. So for the world having all these things to perform, you have to write the application, right? So this particular application, what you are going to write, that will be written inside and it will be stored in the memory. So the memory is used for holding the code. So in the memory, when you talk about, so the fixed memory is one thing. So in the ROM, that is random access read-only memory. So basically, it is used to hold the code or program or for holding the control algorithm. So the most commonly used memory for controlling algorithms are storage or one-time programmable memory, programmable read-only memory, EEPROM, that electrically erasable programmable memory, and then flash. Okay, so these things you have studied, I think, right? So even you know what you mean by flash, right? So flash memory you're going to have. So if you have going to have this particular type of so anybody know what do you mean by flash memory?
Temporary unit to for the functions.
Yeah.
Transfer the functions from main memory to the processor.
Yeah, but it is temporary memory, so you can change the applications. What if you want to change the work which has to be done by that particular embedded system, you can reprogram it. Okay, so you can reprogram that particular application using some burning software. Okay, that you come to know when the software when the program, when your hardware program starts as part of your curriculum. Okay, so what is the flash is going to do, those things you are going to know. So even if you do the flashing in your mobile also, so what it is going to do, it is going to erase all the data which is there inside your mobile devices. So you are doing the same thing there also. You are erasing all the data by doing so. Without our knowledge, what we are doing, we are telling that I'm going to flash the mobile devices. When you flash the mobile devices, so it will bring that particular mobile device to default, right? The same thing happen here. When you do the flash, it will erase all the contents of the memory. That's it. Okay, so in a control based embedded system, what will happen? The controller may contain internal memory or for storing code, or such controllers are called microcontrollers with on chip ROM. So as I told you that we have seen already the difference between your controllers and microprocessor. Your microcontroller will be having its own internal ROM and RAM. So your ROM which is there inside your microcontroller will hold the typical application, what action it has to perform. Okay, so that's what it is going to do. So next we'll go with the elements of the embedded system. Okay, so in the next class we are going to discuss when it comes to the elements of the embedded system which you are going to have, so which we have seen in the figure. So they are going to have the single chip controller which will be acting as the brain of the system. Next is memory, that is nothing but your embedded firmware, so which is going to hold both software and the hardware. So we are going to have the input ports which will be acting as the sensors. We are going to have the output ports which will be acting as the actuators, and you will be having the communication interface. So next is other supporting ICs and subsystems are used. So we will discuss one by one because it is very large. So what are the different elements of the embedded system comprises of and all. So in the next class we will discuss about the different elements of the different elements of the embedded system in detail. So if you have any doubts now, you can ask. So my suggestion is from next class, within 2 to 3 minutes, you enter the class. So if not, it will become difficult for you, difficult for us to monitor. So now I think I have given the assignment. So I just have a, get that particular activity. I will do you people check that one. Have you got the activity link? Can anyone respond, right?
Yes, sir.
Yeah. You just go through the quiz. That quiz is as part of the last class what I have done. Last to last class what I have done. You just go through it. So it's submit by within 10 minutes. So it is going to have 5 questions. So if you have any doubt with this one, you can discuss. If you have any doubt with respect to that particular quiz, you can have that one. Start solving it. Start solving that quiz, and you just so if you have any clarification with respect to the